12:01 p.m. So this is the tutorial session of week 3. I'm going to start the recording and we're gonna get started right away. So for your information, those who just joined, I have unlocked Instat. So please go in and mark your attendance. All right, so today's class is 1 hour. We're gonna try to keep within the time. Okay, so for today, we're going to continue on and hopefully I can complete the chapter 1 topic today. Right, so I'm going to continue on with the complex rational expressions. So far, we have been dealing with rational expressions for the last few lessons. What are rational expressions? It is a quotient. You have a numerator and a denominator. So what is the meaning of complex rational expressions? Complex here means that within the rational expression, you have more, okay, you have more rational expressions within a given expression, okay? It contains additional rational expressions, either in the numerator, as you see here. It can also be in the denominator, as you see here, or it can be in both, as in this question number 1. Okay, so when we are asked to simplify these complex rational expressions, we usually rewrite the numerator, okay, into a single rational expression. Okay, so we work on the numerator and the denominator separately so that it becomes a single rational expression. Okay, so that's the way to simplify it. All right, so let's go straight ahead into this. I'll give it as an example. Simplify 1 plus 1 over x divided by 1 minus 1 over x. Okay, so for the numerator, I'm going to try and convert it into a single rational expression. So with the denominator of x, okay? All right, so it becomes x plus 1 over x. And in the denominator, I'll do the same. So you have x minus 1 over x. Okay, so what's the next step? When you see this term on top dividing this term at the bottom, all right, we have a way to simplify it. The divide, we turn it into multiply. Okay, and then you take the reciprocal of the denominator. So you have x over x minus 1. Okay, so now what are some common factors which you can cancel off? There's the x here and x here. Okay, so you have x plus 1 over x minus 1. So this is the simplified form. Now, whenever we are dealing with rational expressions, we need to be careful about the set of real numbers for this expression. Okay, so in the denominator, we cannot have a 0. So what are the excluded values for x in this particular case? Right, you need to refer back to your original expression here. We cannot have 1 dividing 0. Okay, so here we need to write, okay, x cannot be equal to 0 because we are referring back to the original complex rational expression. Are there any other values which needs to be excluded? Is that all?
Yes.
If you're not sure.
Is it 1?
Yes. Is it 1?
Yes. So you look at the bottom here, right? So we cannot divide by 0 as well. So here, right, x cannot be equal to 1. Okay, you can also get the hint from here. Okay, x cannot be equal to 1. All right, so this is the full solution, all right, the final solution. Next, let's go to question 2. We have a very similar sort of pattern. So let's go ahead. All right, we combine the numerator. 2, okay, over 2x minus 3x, okay, divided by the bottom, 1 over x plus 3 over 4. Again, you convert it, you try to transform it into a single rational expression. So, okay, so you have 4x, 4 plus 3x. Is there anybody who is not quite sure how we get this? You're okay, huh? All right, then let's move on. So now we rewrite this into, okay, 2 minus 3x divided by 2x. Now multiply the reciprocal of this denominator. So 4x over 4 plus 3x. Okay, so in the next step, you can cancel off any common terms. All right, so here can cancel off, you get 2. Okay, so you have 2 minus 3x over 4 plus 3x. Now remember earlier we said that some questions, they might specify you to give the final answer in terms of a polynomial, okay, your rational expression in a polynomial form. So you expand, you remove the brackets, okay, so here it becomes 4 minus 6x over 4 plus 3x. All right, is that all? No.
Miss Maxine.
Yes.
Go ahead. Actually, I have a question on the first question.
Question 1.
Like,
okay.
Question 1. I really don't get, like, how did you get the x plus 1 over x there?
Are you still there?
Yes, Miss Maxine. No, I don't understand how did you get that x plus 1.
Maybe you ask me after the class if.
Yeah, sure.
Oh, okay. Are you still there? What's your question?
No, my question was like, I don't get how did you get that x plus 1 over x?
Okay, this first part here, all right? That means we get this in terms of x over x plus 1 over x, okay? We want to have the same denominator in order to add these two fractions together, 1 plus 1 over x. So 1, you can change it into the form of x over x because we want to have the same denominator here so that we can add. So that it becomes x plus 1 over x. Okay, so this one. All right.
Yes, I understood. Thank you.
Okay, great. So coming back to question 2, okay, is that where we stop with our answer? No, again, we have to specify the set of real numbers that x can take, right? What is the domain for this expression? Okay, x can be any real number except, right? If you look back at the original expression here, 1 over x. So we cannot have x equals to 0. Okay? Any more?
Negative 4 over 3.
Yes, x cannot be equal to negative 4 over 3. How do we get this? So again, you take a look at this part here. So 1 over x plus 3 over 4, if it is equal to 0. Okay, so 1 over x equals negative 3 over 4. X equals to, okay, you do cross multiplication. So x becomes negative 4 over 3. if the denominator is 0. So here x cannot be equal to negative 4/3. So that's how we get this. Okay, so please remember you must always write out the excluded values. Now moving on, okay, to question number 3. So here, instead of using a real number, I substitute with a variable. I'll just call it h. So here we have two unknowns, the x and the h. Okay, so don't be scared if you see more than one variable, right? You just try to simplify it. So again, this is a rational expression. It's a complex rational expression because you have additional rational terms within this larger rational expression. Okay, so how do we deal with it? You must try to combine your numerator into a single rational term first. Okay, so you can combine the denominator. So I'm working on the numerator's denominator. So x plus h and x, okay, two very different denominators. So I'll just have x multiply the x plus h. Okay, so here I will have x, okay, and then minus x plus h over x plus h. Okay, so now they have the same denominator, and then the whole thing divided by h. Okay, so now you can combine the top, so x minus, okay, remove the bracket, okay, divide by, okay, so now we have combined the top, the numerator, into this form. So the whole thing we divide by h, isn't it? So instead of writing divide h, we write multiply by the reciprocal of h. That means multiply by 1 over h. Okay, so now this makes it easier for us to simplify. X minus x is 0, so you are left with negative h over x squared plus hx. All right, and then multiply by 1 over h. So it turns out that, yeah, we can cancel off the h. So now it becomes negative 1 over x squared plus hx. Okay, again, what are some values which we need to exclude from the real set, the set of real numbers? Okay, that would invalidate this expression. So x cannot be, okay, you look at here, x cannot be 0. Okay, any more? Because now we have two variables here. We have x, we have h. So if you take a look at here, okay, h cannot be equal to 0. Yes.
Negative h.
H cannot be. Oh, what happened? H cannot be equal to 0 anymore. If you look at this rational expression, the denominator is x plus h, right? So you can say x cannot be equal to negative h. Okay, so we have we have to write these three statements. Okay, any questions about this?
Miss Maxine,
Yes.
I don't get it why you said x cannot equals to negative h.
Okay, so if you look at this rational expression 1 over x plus h, okay, if this denominator equals 0, okay, that means we get 1 over 0, okay, so this is undefined. We cannot divide a number by 0, all right, so x plus h, if x plus h equals to 0, so x will be equal to negative h. But we cannot have this situation.
Okay.
Because we cannot divide by 0. So therefore, x cannot be equal to negative h.
Okay, thank you.
All right. Okay, so I have the next section is word problems. So now, actually, I want you to do a short quiz. All right, I prepared 5 questions on complex rational equations. So please go to this link, or you just type it in your computer or on your phone. All right, joinmyquiz.com, and you enter this code 903751. All right, so I'm waiting for you to join. All right, yeah, please try to use your name. Are there any more?
Wait, miss, sorry.
Okay. So I have 127 students. Any more? One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so I guess that's all. Who is this with a dot as your name? All right, you want to remain anonymous. Okay, and a smiley face. Is that all? Okay, Alice. All right, I'm gonna start, yeah? Okay, yes, Zhenhe joined. Okay, I'm gonna start.
Miss, if you multiply, sorry, if you want to flip the fraction, or if you want to get rid of the fraction, you have to multiply by the reciprocal.
Yes, if you are dividing by a fraction, then you can change it into multiply the reciprocal of that fraction. Okay, we have some students who have already completed. Okay, I'll just give about 2 more minutes. Okay, the time is 4:25. I think we should stop. All right, so I'm going to end this quizzes and then we're going to discuss. First of all right, well done, Xueqin, Jian, and Daryl. Good job. Okay, many of you also scored all correct. Well done. Okay, so let's have a look. Which one was the most problematic question? Okay, so let's review. So most of you got this correct. Now, some of you, maybe you made a mistake in the reciprocal, right? So if you can take 1 over k plus 2 and then multiply by the reciprocal of 5 over k squared minus 4. All right, I'll just go to this OneNote. sorry. All right. So how would you do this? You can take 1 over 2 multiplied by the reciprocal. K squared minus 4 over 5. Okay, so if you did not do that, then you would face a problem. The k squared minus 4, you can factor it into k plus 2, k minus 2. Okay, and then from there, just cancel off the common factors. So what is left behind will be k minus 2 over 5, right? Or the second question. So this one, more of you got it correct, yeah? All right, so I won't go into the solution. Okay, here. So what happened here? 6 minus y over 6 and divided by. So you don't have to do anything to the numerator in this case, you just leave it, all right? Combine your denominator. So you have y minus 6 over 6y. All right, so from here, multiply the reciprocal of the denominator. 6y over y minus 6. Okay, and then cancel off whatever common terms you see. All right, 6 here, 6 here. All right, now notice that 6 minus y, y minus 6. Okay, so they are pretty similar. So you can convert this into negative of y minus 6. Okay, so if you have y here and then y minus 6 at the bottom, so you will be able to cancel off and you will get the answer negative y. So the answer is negative y. So maybe some of you were confused. All right, moving on. Okay, again, for the next question, you try to combine the denominator again. Okay, should be a pretty straightforward type of question. I would like to know, did you have sufficient time or did you need more time to simplify this?
Needed more time.
Yeah, I needed more time.
So
I see.
basically the time allowance is the thing that struggle us.
I see, I see. Okay. I think I allowed 60 seconds for this. So you need longer, huh? Okay. All right.
Yeah, this question
Finally,
it only have 50 question, I think. 50 second, I think, for me.
Okay. So average time taken for this previous question was 41 seconds. All right. The next, okay, this is the last question. So simplify this. This is actually from question 4 in the chapter notes, question 4. Okay, so simplify this given rational expression and then state the set of real numbers for x for which this expression is defined. Okay, so, oh, sorry. So the answer here doesn't show up properly if I reduce the window. So here, this is the correct answer. All right, so I think some of you were missing the negative sign at the front. So I think that is the main issue. Okay. All right. So we'll stop that. And take a short 5-minute break.
Okay, thank you, Miss.
All right.
Thank you, Miss.
Okay, hello, I'm back. Let's continue with the lesson. By the way, I've just unlocked Instat again for those who missed putting in their attendance at the beginning of class. So please go ahead and mark your attendance. All right, so let's continue. So this is the final section of
what is the common
chapter
monomial
1.
factor of 6x
We are going to deal with
plus
word
3x
problems.
squared minus 12x?
Now, generally, algebra is used to solve practical problems. So it is necessary, it's a necessary skill for us to be able to translate verbal statements, all right, sentences, or some story about a problem into mathematical equations or mathematical statements. All right, so we need to be able to transform certain phrases into mathematical symbols. So some of the common phrases which you might come across are these, okay? In this table here, you have things like equals or is equal to or will be or the result is. So all these, we use the mathematical equal symbol. All right, so sometimes the statement might say added to or increased by, or something is more than something else. So here it implies addition. So you need to use the plus symbol. The opposite, all right, if you hear or if you read something that says decreased by or the difference is, okay, or reduced by or less than. So then we need to use the subtract symbol, minus. Okay, when do we use multiply? Okay, if we come across the term like the product, okay, the product of two numbers, that means we are multiplying two numbers. Okay, then the opposite of that will be the divide symbol. All right, so sometimes you might come across the ratio of two numbers or the quotient. Okay, they mean the same thing, so we need to use the divide symbol. Okay, so here are some guidelines to solve word problems. Okay, so first of all, when you read the problem, perhaps you need to read it more than one time. Okay, so you read and then you understand what the statement is saying. Sometimes you need to draw or make a sketch. Okay, this could be necessary in order for you to be able to write out the mathematical statement, okay, from your sketch. The next guideline would be identifying the unknown in the problem. Okay, so you can use some symbols to represent these unknowns. So when you are solving the word problems, you need to write out, okay, X represents what, Y represents what. Okay, so once you have identified and you named these unknowns, then you form some equations to link these variables together mathematically, right? So you express all the relationships mathematically. Finally, you solve the equation. So oftentimes you will have more than one equation. Okay, so then you can solve the problems using simultaneous equations. And finally, you always check your answer. Okay, so whatever answer you get for X or Y, you try and substitute it back into your original equations and you see whether it fits. Does it make sense? Okay, so always check your answer. All right, so we have a few examples here. Okay, very simple examples. All right, translate the following verbal phrases into mathematical expressions. And you can use the symbol X to represent the unknown. All right, so I'll go through all this. So a number increased by 8. So this is the unknown, right? So the number here, this is the unknown. So we'll just call it as X. So how do you transform this into an expression, an algebraic expression? You just say X plus 8. okay, the number x increased by 8, so x plus 8. Okay. 9 decreased by a number. Okay, this is question number 2. 9 decreased by a number. So whenever you see the number, what number? Okay, so we'll just call it x. Okay, so 9 decreased by a number, so 9 minus x. All right. Now go to question 3. The product of a number and 5. So when you see the term product, straight away you think of multiply, okay, of a number. So this one will be your x and 5. So 5x, right? This is the product of 5 and the number x. Okay, next, 6 more than a number. Okay, so again, here you use x to represent it. 6 more than x. So how do you write it? Using the symbols. 6 plus x. Okay? Moving on. Okay? 12 decreased by twice a number. Okay? So here 12 decreased. You can think of 12 minus by how much? Twice a number. Twice means 2 times. So 2x. Okay, 12 minus 2x. So far, is it okay?
Yes,
Right.
miss.
Yes, miss.
Okay, great. Next, the quotient. The quotient of a number and 2. That means the ratio of x and 2. So x over 2. Okay. And finally, 2/3 of a number. 2/3 of here also implies multiply. So 2/3 means 2 over 3 of a number. So 2 over 3x. Okay, so it's a very simple example, all right, how we are going to translate these statements into mathematical expressions. Now let's take a look at some exercises. Just 4 exercise problems here. You have more complicated, more involved word problem questions in your tutorial. So I know some of you have already tried the tutorial. If you haven't, please do it by this weekend. All right, so let's go into exercise question number 1. Okay. One number is 1/3 of another number. If their difference is 28, find the 2 numbers. Okay. So this is a bit more complicated than the example. So you have one number, you can call it x, the first number. Okay. Another number, you can call it y. Alright, so how do you link these two as a statement? So you can say x is 1/3 of another number. So x equals 1/3 of y. Okay. So oftentimes in this type of word problems, you have a few mathematical equations. So this is the first one here. Okay, next, if they say if their difference is 28. Okay, so the difference. So you can say x minus y equals to 28. Okay? You can also come up with an alternative statement, you know. Okay, this is your second equation. Or you can also say y minus x. What if y is bigger than x? Oh, okay. So then y minus x equals 28. Alright, so this can be your alternative second statement. So we'll just call it number 3. Okay. Alright, so you can solve this simultaneously and you can find x and y. Alright, you have enough information to find x and y. So can you work it out quickly? What is x and what is y? You just substitute 1 into 2. And again, you can substitute equation 1 into 3. So can you find quickly what is x and y?
Is x 42 and y 126?
X is 40. I think you got one of the numbers right, but the other number, no. Try again. Alright, let me this and I will do it. Okay.
Miss Maxine?
Yes.
What? Negative 14 and negative 42.
Yes. X equals 1 over 3y. X minus y equals 28. Okay. So you substitute. Okay, 1 over 3y minus y equals to 28. So here, minus 2 over 3y equals 28. So y will be negative 42. Alright, then x will be 1/3 of negative 42. That will be negative 14. Okay, so this is one set of answers. But then you have another statement. You can see y minus x equals 28. So this will be our third equation. Again, you substitute. Alright, x equals 1 over 3y in here. And then you will find that y equals 42 and x equals 14. Okay, two sets of solutions. Alright, let's go to the second question. A woman is 30 years older than her daughter. Find the daughter's age when she is 1/3 her mother's age. Very interesting. So again, when we deal with this type of problem, we need to define, okay, what is the unknown. So you can say the woman's age, the mother's age, okay, the mother's age. Okay, I'll use the symbol M. Okay, the daughter's age. I'll use the symbol D. Okay, and so once we write out these unknown, we give some symbol to the unknown, then we can write the relationship between these. Okay, so a woman is 30 years older than her daughter. So that means the mother's age is 30 plus her daughter's age. Okay, she's 30 years older than her daughter. So you will write this first equation. Okay, equation number 1. Right, then find the daughter's age when she is 1/3 of her mother's age. So if the daughter is 1/3 of the mother's age. Okay, so this is our equation number 2. Okay, so when you have two equations, it is sufficient because you have two unknowns, then you can solve. So the important step in this type of word problems is you must establish, okay, what symbol you want to use to represent the quantity, the unknown. Okay, then you need to write out this mathematical equation. Then you solve. Okay, then you check. All right, so if you substitute this in, okay, substitute 2 into 1, what do you get? All right, you can find it for me. You will find that M, the mother's age, will be 45. Okay. If you substitute D into here, so M equals 30 plus 1 over 3M. All right, so M will be 45. And then when M is 45, you can find D. D will be 1/3 of 45, so it will be 15. Okay, so you check back. All right, so you check your answer. Okay, the woman is 30 years older. Yes, 15 plus 30 is 45. Yes, so it works out to be correct. Any questions regarding this? I hope you understand. I think the important thing is you need to understand the process to solve it. Okay. Okay, each question will be different. The third one, you have a rectangle. So the rectangle has a perimeter of 132 cm. Okay, so you just continue reading. Its length is twice its width. Find the dimensions of the rectangle. Right, so here it might be useful to sketch a rectangle. The sides are longer. All right, so the perimeter, we use the symbol P, is given as 132 cm. Right, so this is the length, this is the width. We'll just use the symbol L and W for length and width respectively. Okay, so find the dimensions. That means you need to find what is L, what is W. Okay, so can you work it out? What kind of mathematical equation can you write out from here? Any volunteers?
2L plus 2W equals to 132.
Yes, right, because perimeter is 2L plus 2W. Yes, and we were given that it is equal to 132. All right, any more?
L equals to 2W.
L equals to
So what other information is given to us? Because we need to solve for L and W, right? All right, so far we have the first equation, but we need another equation. All right? So look at the second sentence. Its length is twice its width. So can you translate that into a mathematical statement using L and W?
L equals to 2W.
Correct. L equals to 2W. Okay, so this is your second equation. All right, so now with this, you can solve. Okay, so can you quickly tell me what is L and what is W? What is the length and what is the width?
Is the length 44, width 22?
Length is 44, width is 22. Okay, so it's in cm. All right, anybody else can confirm that? Okay, I'll confirm it for you. Okay, that's correct. All right, finally, the question 4 here. A closing down sale. All right, unfortunately, this shop is closing down. It has to sell all the items by a reduced price. Okay, all items reduced by 45%. what is the original price of the clock, which is now priced at 41 ringgit 25 cents. Okay, for our international student here, RM stands for Ringgit Malaysia, our currency. Alright, so what is the original price? So this is the discounted price. Alright, so let's take a look at this statement. All items reduced by 45%. So the discount is 45%. So the reduced price is 55%. Okay, from the original. Alright. Okay. Right, so you can say that, right, reduce by 45%. So that means the discounted price is actually 55% of original price. Okay, so we can say that X is the clock's original price. Okay, this is just an example of how I will write the statement. Okay, so the discounted price will be 41.25. So 55 over 100 of the original price equals RM 41.25. Okay, so now you can work out what is the original price from here. The original price will be 75 ringgit. Alright, so please do try out all the tutorial 1 problems. If you have any questions, do contact me. I think many of you have already tried it. I will be releasing the full solutions today. Okay, so we'll stop here. Yes.
For the 75
Yes.
ringgit, I put as 74 ringgit 55 cents. Is still accepted?
Okay, how do you get that?
I got that.
41.25 times 100 and then divided by 55. It works out to 75 ringgit exactly.
Okay, I'll check back.
Okay. Alright, so we'll stop here for today. Alright, I'll see you again next week. We'll move on to chapter 2. By the way, September 30th is our first quiz. Right, and we will be focusing on chapter 1 only for the first quiz, for part 1 for my part. Alright, we'll stop here for today. Thanks everyone and have a great weekend.
Thank you, Miss.
Thank you, Miss.
Bye.
Bye-bye.
Thank you, Miss.
Thank you, Miss. Thank you, Miss.
Thank you. Have a good weekend. Bye-bye.
Thank you, Miss.
Bye.